Welcome back. So in this video we'll be talking about sketching quartics. So we're going to be given a function of a quartic and we're going to be sketching it on a y and x axis. So quartic, remember, so that means we're going to have x to the power 4 and that's going to be your highest order term. So you're not going to have x to the power 5, x to the 6, nothing like that. But you can still have the lower orders inside your expression. So over here, we can tell this is a quartic because you have 4 linear factors multiplied by each other. So when you have 4 linear terms multiplied by each other, this means that the highest order you can get is 4. And this is already quite a convenient form because if they're all in 4 different brackets and there's nothing on the outside here, this means it's already an x-intercept form. So each bracket actually refers to an x-intercept. So over here, x plus 2 refers to negative 2, 0. Over here, x plus 1 is negative 1, 0, and so on. So what we're doing is, we're really just reversing the sign of the constant and dividing it by the coefficient of x. But in this case over here, all of our x's have a coefficient of 1. So let's just look at the constant. So when we sketch it out, now we're also going to expect a y-intercept at some point, aren't we? Because it is a function after all, and it's over all real numbers. So let's find out what that is. Y-int is when x is equal to 0. So summing all that in, f of 0 is equal to 2 times 1 times negative 1 times negative 2. So we get 4. Okay, so we sketch this out. Label all the points that you have. So you get negative 2 over here, negative 1, 1 and 2. So I'm just labeling them as numbers now. You should really label them as coordinates, but there is a little bit of blank space here. And we also have 0, 4 at the top over here. And since this is a positive quartic, I'm going to start from the top, going from left to right. I'm going to end up back at the top as well, for an even order function. So goes down through this x-intercept, through the y-intercept, back down and back up. So we're just going to make sure we hit all of our intercepts and also start from the top and end at the top. If it's a negative quartic or some sort of negative even order polynomial, it's going to always start from where it begins. Sorry, I should say it ends where it begins. So for the negative quartic down here, we're going to expect it to start from the bottom and end at the bottom. Let's observe a couple of things first though. This one over here says it's a negative quartic. Over here, we have x plus 2 to the power 3. Whenever something is to the power of 3, we should think about cubics. What does a cubic have? It has a square for some of them. So in the case of the x-intercept form, when your linear factor is to the power of 3, you know you have a stationary point of inflection at that intercept. And of course, this just cuts through the x-axis. And we are going to hit the y-axis at some point, so let's work that out. Okay, so when x is equal to 0, your function is going to be equal to negative of 2 cubed times negative 3. So we're going to have these two negatives cancel out. We're going to have 8 times 3. Okay. So we're going to hit the y-axis at 0, 24. We're going to have a stationary point of inflection at negative 2, 0. And an x-intercept at 3, 0. And from here, start at the bottom. We know this is a spoil, so let's remember that while we're sketching. Start from the bottom. This is going to inflect this point, so it's going to be flat temporarily. Go back up, back down through the intercept. Just one moment while I'll get the lights back on. Okay, and so this is what the negative quartic will look like, since we start at the bottom, end at the bottom. Just got to remember this is a stationary point of inflection here for the third power. What about this quartic over here? Well, we know it's a quartic first of all because we definitely have our highest order term here, because when you expand this out, we are going to have x to the power 4 at some point. But the rest of it kind of looks complicated to graph. So we actually got to work with the algebra here a little bit before we can actually get to our graphing stage. So we notice there's a pattern of x plus 1 here and here. Recall from your index laws that if you have x plus 1 all squared, and you want to square this again, so I'm going to put this on the outside, that when you expand the indices here, these two are going to multiply by each other. So this is equal to x plus 1 to the power 4. Now what we're going to do over here is we're going to say the inside here, x plus 1 all squared, we're going to let this equal to a symbol, some sort of polynomial, a. So let a equal to x plus 1 all squared. And so we're going to sub in every time we see x plus 1 squared with an a in this original function. F of x is equal to a squared minus 8a plus 16. From here, you can easily see that if you're going to factorize this in terms of a, it's very simple. We're just going to have a perfect square over here. We're going to have 8 minus 4 all squared. Now, if you sub x plus 1 squared back into here, just use bigger brackets here, we're going to have x plus 1 all squared minus 4. Remember that we have a square on the outside. What's inside over here is, it's kind of familiar, doesn't it? We got a perfect square here. 4 is a square number. If we have the difference of two squares, we use a formula here, where we got x plus 1 plus 2. So what we did here was we took the square root of the first plus the square root of the second, and then we do the opposite procedure. X plus 1 minus 2 this time. And I'm using the big square brackets just to show that we still have everything to the power of 2. Okay, so let's just simplify the little ones in here. So x plus 1 plus 2, x plus 3, x plus 1 minus 2 is x minus 1. If we have all this to the square, we can distribute the power to each bracket. So you're going to have a square term for each bracket. Okay? So from here, you can see that you're going to have two x-intercepts. And since they're both to the power of 2, what does that tell us? This tells us that both of these are turning points, or have this parabolic shape. So when we sketch it out, okay, so I was going to sketch it out, but of course we do know that it hits the y-intercept at some point, so we can work that out. Either use the expression down here, you can use the one on top as well, doesn't matter, remember they're both the function of x. So when f of x is equal to, when x is equal to 0, your function is going to equal to 0 plus 3 all squared, so 3 squared, plus negative 1 squared. So we have 9 over here. So this gives us a y-intercept of 0, 9. 0, 9. We've got an intercept at 1, 0. And another one at negative 3, 0. We know it's a positive quartic, so we're going to have some sort of W-looking shape, starting from the top, ending back at the top. So as we go down, remember we got the turning point over here, so let's go back up. It has to go through the y-intercept, and we're going to go back up over here. So just remember we're turning at both these intercepts because of the power of the chip. Okay, that's about it. Thank you.